Here we want to identify the reaction as redox reaction or not. And if it is a redox reaction, they want to know what is the oxidizing agent and what is the reducing agent. And so to figure out if it's a redox reaction, we have to see if something is changing oxidation state. And in this case, we've got sodium carbonate, which is a base. We've got phosphoric acid, which is an acid, right? This is not a redox reaction. This is an acid-base reaction. So we would say no, there's no redox here. We could go through and assign sodium's +1, hydrogen's +1, phosphates 3-, sodium's +1 over here. Carbon is 4+ here, it's 4+ here, oxygen's 2-. None of these oxidation states change in this reaction. It's simply an acid-base reaction. However, the next reaction, I've got nitrogen gas reacts with oxygen gas to form dinitrogen pentoxide. And so in this case, to figure out our oxidation state, we need to kind of figure out what's the charge, what's the assigned charge on nitrogen and oxygen in the dinitrogen pentoxide. And to do that, we can split it up into 2 nitrogens and 5 oxygens. The whole thing needs to be neutral, and to do that, right, we know oxygen is always -2, so that means I got a total charge of -10 from oxygen. I need to have a total charge of +10 from the nitrogen for that to balance out. So I would call each nitrogen 5+, would be our assigned oxidation state. Now that we've identified this as a redox reaction, we want to figure out what's the oxidation half, what's the reduction half. And so if we look, nitrogen goes from 0 to 2 nitrogens at 5+ each. How did that happen? Right? It did that by losing 10 electrons. So that is our oxidation half reaction. That makes nitrogen our reducing agent. Because remember, our reducing agent causes reduction by it itself getting oxidized. So nitrogen is our reducing agent. Now we can look at oxygen, right? Oxygen goes from 0 to, and we'll just look at, well, we can do, to keep it balanced, we'll say I have 2 nitrogens, which would make this 4 nitrogens here and 20 electrons here, so that we could say I've got 5 oxygens here that end up as 10 oxides here. So how do I go from oxygen 0 to oxygen that's 2-, right? We had to add in those 20 electrons. So that's our reduction half reaction. Because that's our reduction half reaction, right? Oxygen is our oxidizing agent in this reaction. The next reaction is also a redox reaction. We've got iron reacts with copper 2 sulfate to give us iron 2 sulfate and copper. So here again, anytime we have a pure elemental solid, the oxidation state is 0. So iron is 0, copper on the end is 0. Sulfate is 2-, which means copper is 2+. Sulfate's still 2- over here, which means iron is 2+. So the 2 half reactions that we have, iron goes from 0 to iron 2+. Copper goes from 2+ to 0, right? To balance that out, we need to add in our electrons now. We add in our electrons, copper, iron going from 0 to 2+, right? It lost 2 electrons. So that's our oxidation reaction, but that makes iron our reducing agent. By default, copper must gain those 2 electrons, so that makes this our reduction half reaction, and that would make copper our oxidizing agent in this redox reaction. So the first step, we want to assign our oxidation states. Once we've got assigned our oxidation states and the reactants and the products, we can go and then add in where are our electrons, what's losing electrons, what's gaining electrons, to identify what's our oxidation half reaction, what's our reduction half reaction, and then we can identify our reducing agent and our oxidizing agent. Our reducing agent and oxidizing agents will always be reactants in these problems. Some students in office hours wanted to assign this to a product. No, that is the product of oxidation. That is the product of reduction, not what is causing the redox reaction to take place. So it'll always be one of our reactants.